Have you ever thought about why laser weapons don't work? But now, it's back again. From the earliest bow and arrow, long-barrel bullet, to modern tank bombs, anti-ship missiles, almost all weapons rely on motion to destroy the target, throwing an object at a very high speed, crashing another object. This logic has been going on for thousands of years. However, the battlefield environment has changed dramatically in recent years. Cheap small UAVs come together, and fast hypersonic missiles keep coming. These new weapons have completely subverted the cost-effectiveness of the traditional anti-aircraft missile system. It is in this situation that military engineers once again focus on a weapon that has existed for a long time, but has been misunderstood for a long time: laser. The biggest advantage of laser weapons is that its cost of use is almost zero. For example, the US Navy's CRAM gun fires 4,500 high-explosive nightlights every minute. Each is about $27. In just a few seconds, it burns out nearly $7,000. But a high-capacity laser weapon of 250,000 watts has the same interception action and costs less than $25, and there is no need to replenish ammunition. This not only means extremely low long-term spending, but also achieves higher accuracy, lower load damage, and almost infinite sustained combat ability. So laser is becoming a key supplement to the layered defense system. But why didn't laser weapons rule the battlefield during the Cold War? This is actually a huge red hook between technology and reality. In ancient legends, Archimedes lit a Roman warship in 212 BC. But this is more of a storytelling exaggeration, not a truly weaponized laser. In the Cold War, the United States proposed the idea of using space lasers to intercept missiles, but was limited by technology and cost. Enter the 21st century, the United States developed the YAL-1 space laser project and installed a chemical laser in the Boeing 747. It did hit a missile in the test, but this chemical laser system occupies the entire fuselage, is huge and complex, and costs up to $20 billion. In 2011, it was eventually ruled impractical and canceled. In other words, the failure of early laser weapons was not because of the wrong principles, but because of size, cost, and efficiency. The three mountains crushed it. Today, the situation is different. With the breakthrough of electromagnetic, solid-state laser, and optical technology, electromagnetic laser has replaced chemical laser and has become a truly expandable and deployable weapon. Modern high-capacity laser systems can be compacted and modularized, and the power output is greatly increased without need to sacrifice volume. What's more interesting is that the way these laser cannons are operated is actually aimed and fired through a handle similar to the Xbox. The operation is so simple that newbies can learn it in a short time, but it also has a significant shortcoming. The biggest problem is that the light can only be transmitted in a straight line. So when encountering heavy fog, rain, dust, or strong radiation, the effect is greatly reduced. This is why laser weapons are more suitable for use in clear weather, open air, or high-altitude environments, and not suitable for completely replacing missiles in complex climates. But this does not prevent it from becoming an ideal choice for dealing with drones, wind groups, rockets, and short-range targets. Interestingly, the role of laser in the military is not only to burn targets, but also to help feed drones. Scientists study the movement of fish groups and use laser tracking and stimulation of individuals in the fish group to discover how groups change overall due to structural changes. The principle of group intelligence is used to train drone wind groups so that they can work together like a living creature to avoid obstacles and even explore in the unknown environment. These training methods are completed by combining laser measurement and AI. DARPA's Offset project uses 3D laser radars to scan urban environments, build virtual spaces, and use virtual reality helmets to train AI models. In the end, drones in reality can perform tasks independently in a way that is similar to natural groups. This is the future of drone wind groups. Further, laser can also solve the battery life of drones. Battery capacity restrictions have always been the bottleneck of drone tactics, but laser provides the potential for so-called energy transmission. By radiating the laser to the light-absorbing receiver, energy can be directly converted into electricity. Drones can replenish energy in the air without having to return to the base. Since 2017, the U.S. Naval Research Laboratory has been testing this power tree technology. The experiment successfully transmitted 400 watts of energy across hundreds of meters to the drone receiver. Although the power is not large currently, it proves the feasibility and scalability of the method. If this technology is mature, future frontline operations will no longer require huge fuel supplies and radio waves. The logistics system will completely be subverted. A bolder vision comes from space even. The U.S. Air Force Research Laboratory is promoting the Space Solar Energy Project. The plan is to collect solar energy on a satellite and then use a fixed energy technology to directly transport energy to the Earth's receiver. This not only provides the frontline combatants with inexhaustible energy, can even change the global energy pattern and become a subversive technology for both the military and the people. Of course, the problem also comes with it. If the energy beam is misplaced in the wrong area, what will happen? No one can give an exact answer at the moment. All in all, laser weapons have been judged to be a failure because of their expensive, heavy, and unrealistic practicality. But the reason why they came back today is because of the perfect combination of realistic battlefield needs and technology. Drones, wind groups, low-altitude small targets, and high-altitude intercept pushed the traditional missile defense system to the brink of collapse. High-capacity lasers just filled this gap. Although they are far from the ultimate weapon, they are still restricted by weather, power, and data. However, laser weapons have gone from the fantasy of the Cold War to reality and become a new choice that cannot be ignored in the 21st century battlefield.